Alrighty, so in the first video I made, I talked about how I'm building this cameraman application to control the open broadcast software I use for doing these video recordings, and how in my normal workflow I have 3 monitors. And as you can see here, I've got my cameraman app working somewhat decently. As I move my mouse around, it's adjusting the monitor appropriately, and when I start talking, it's bringing up the camera. When I put my mouse in the bottom right in the way of the camera, it sends the camera away and brings it back, and it's working okay. And my cameraman app looks like this. He's got a couple different tabs where he's monitoring a lot of different variables. I've got my Belkin Wemo light switch controlling my lighting, and the logic's pretty robust. However, I've currently got the state switching logic implemented using this rather than hand-coded state management. I've got these this pretty nice looking XAML syntax that I created, which is pretty nice for managing really small state. And a good example of that where it's used appropriately would be on my data grids, for instance. I've got a little bit of logic here where when the column width goes below 600, I automatically hide a column, and I can see that happening here. When I bring this down, that column comes and goes away. And on the logic here, I've got that set up with a 1/4 second delay. And the nice thing about that is if I am dragging the thing really fast, the column only comes up when the condition's been true for a 1/4 second. And those sort of delayed effects are really nice. I'm currently using that to debounce. Like right now, if I move the mouse out real quickly, I've got a delay set where the condition has to be true for a 1/3 of a second before it'll actually kick. So for debouncing things, the wind behavior makes it really easy to set those up for basic interactions. Here we've got a simple condition, if then else, and that's basically it. So if the condition is true, it's going to do this. If it's false, it's going to do that. And whenever there's a state change, it's going to monitor it for a 1/4 of a second before it actually executes the action. And I've got a whole range of actions that can be done, and that's all part of a WPF framework that's going to be released on GitHub here soon. And I have a really large framework. The whole thing is going to be going up on GitHub this week. The WPF part is going to be kind of a extreme beta. It's an amalgamation of utilities that I've put together over the last 10 years or more. And the WPF part is a little bit more raw. I've not put as much effort in going through that and cleaning that up until the last couple weeks. Some of the stuff I built, like this wind behavior, I built that maybe way back in like 2008, and I have this I believe it still shows up in the store. Let me see. I built this Visual Studio extension called the Assembly Version Manager. Let me see if it still shows up in the store. Assembly Version Manager. I put the whole thing in the search result. Now, if this thing's filtered down for which Visual Studio I'm compatible with, it probably won't show. Let's click on more info on one of these. And then in here, where's the search button? assembly version manager. There we go. Wow, we got a pretty decent amount of installs there. But the last time I worked on this, let me see when it's got even, 2010. This is back before the days of NuGet. So I kind of let this thing go by the wayside because NuGet's pretty nice, and it like nowadays I would set up a CI, a continuous integration server, and a private NuGet repository for an internal company for internally managing assembly versions and whatnot. So this was back before the NuGet days. I built this extension, and it had a pretty nice little UI where it had some animated effects and whatnot, and those were implemented using this win behavior. And I built it back in those days. And when I built this, I was pretty proud of it. And I planned on putting that out as an open source utility, the win behavior, but I just never got around to it. And then for some client projects where I worked on UI, it seemed like the needs were always a lot more complex and more business apps where animations and such weren't really that kind of critical. So I never ended up needing to bring this up and kind of to a more stable state for any client work. And I haven't built for myself any any real desktop apps that needed to be much more than basic utilities. So when I decided to make this cameraman, and I thought, looking at some of the WPF utilities I'd created in the past for Living Agile, that seemed like one that I wanted to bring up. So I hadn't looked at that code since 2010, really, and it had some cool things, but a lot of glitches as well. So for me to work on it for this app, I had to do a bunch of improvements and fixes, and I'm using it in this app in a much more robust stress test kind of scenario than I was back in 2010. So a lot of the kinks really showed up quick. Whereas for my old project, it was working fine because I hadn't really pushed it to the limit. But now that I've pushed it to the limit here, I've kind of pushed it past the limit for keeping track of all my state properly, so that I can have real fine-grained control of when transitions are happening. Is really hard with this XAML syntax, because I'd like to have conditions that apply when I'm in a certain state on how to transition out of that state when the rules would allow it to transition out. And like, here's a good one. When it's on the big camera, I want to have rules for controlling how frequently that can be engaged and how long it has to be on once it is engaged. And I've got a lot of those coded in terms of the data points, and I sort of kind of have them programmed in using the win behavior to specify the rules, but getting it to where I've properly coded all my rules using these if-thens, it starts to get a lot more complicated, because it's not a simple if-then anymore. Like, my monitor switching logic is really simple. If it detects the mouse is over the left, switch to the left. If it detects it's over the right, switch to the right. That's a really simple case, and that's why that logic works so well. My mouse tracking logic seems to be showing pretty flawlessly. But for making sure that I have the rules in there properly, like the minimum time it has to have the camera on, like getting that rule setup, just using these like binding conditions, is pretty complicated, and doing nested if-thens, while technically the framework supports that, it gets pretty confusing to figure out how to design those all. So I pushed past, for controlling the camera logic, this XAML-based approach, where I'm basically coding the UI using this XAML syntax. It's a little bit pushed past the breaking point. But the nice thing I've got is that it is working okay. So I will kind of like snapshot this and save this as a point in time. In fact, I'm going to go ahead and do that right now. I'm going to be making some changes here live. To API for and I'm going to go ahead and push those changes. Let me make sure my API branch is updated as well. Type in these comments real quick. And push that as well. I like to push all my changes just to make sure if my computer were to crash that I've got that stuff retained, even though it's only me working on it. I'm not too worried about like there's no other people committing changes or anything that I have to pull in, but just doing a local commit's fine, but I want to make sure I'm getting stuff pushed up to the server pretty frequently. So in the comments there, I was talking about an issue. The code I just checked in this framework, I've got this thing called the reactive view model. And the reactive view model I'm using heavily in the Cameraman app. It provides, it's a base class for building view models, and that's also part of the presentation framework. And it has read-write properties as well as calculate properties. And calculate properties are read, but they are implemented as really simple just statements where you just evaluate whatever conditions you need, and these are typically going to be read-write properties that it's hitting, but they can also cascade where you can have a calculated property that depends on other calculated properties and whatnot, and the dependencies are evaluated at runtime. So if the underlying dependencies get invalidated, it should bubble up and invalidate the calculated properties as well. And in my previous video, I was getting some heavier CPU usage than expected, and some of that had to do with timings. And in my app, I've since added adjustable timings on every tab where I can control how frequently things are happening. And as a result, I'm getting, I even did this in the previous video, I made some adjustments, and as a result, the cameraman, his overall CPU usage had gone way down. And at this point, he's running debug mode, so he's using a little bit more than it would otherwise. But I've got extra logging and such. But the other change I made since then is I went into my reactive view model code, and I added some tests. Let me minimize the static methods. So I had these tests to using a XUnit in this WPF fact extension, where I can easily write UI coded tests. Really nice extension. Let me check what that package is called in case anybody's interested. The STA fact. So you can pull that in from NuGet. But I made these basic view models that'll have like a calculated property where he's really only just taking a read-write value and adding one. And then I evaluate those conditions. And what I wanted to see is to make sure that it's only raising certain property changed events. So I added unit tests for all that. So we're going to make a change. Look, if I change the value, I'll see that the calculated property comes up with the correct value. And then I also am monitoring for all the change events. And then I'll do some assertions to make sure I get exactly the change events that I'm expecting and no more. So I went through a bunch of different conditions where I've got a parent-child and a grandparent, parent-child, all kinds of different scenarios to make sure that I was only getting exactly the right amount of notifications. And before I wrote these tests, it was doing, it wasn't caching the state in a very robust way, so I was getting a lot more notifications. Now I have the calculated properties caching their previous values, and when they detect a dependency change, they go ahead and reevaluate themselves, and if the value hasn't changed, they don't raise a notification anymore. Hi, dog. My dog Porter came to see me. Hey, buddy. You're messing up my green screen. Here, go to your mat. Go, Matt. So anyway, now that I've got that stuff done, the cameraman uses a lot less CPU than he was previously. So even if I crank up some of the timing intervals to happen pretty frequently, my overall CPU usage is really low because the UI isn't having to reevaluate those conditions as often. So that's pretty cool. Again, this is all part of the WPF framework that's going out. So the reactive view model is a really nice shortcut for not having to manually do things where a very common scenario would be something like you might have a view model that has a first name and a last name, and then a property like full name. And so in a traditional view model, like when the name property changes or the first name property changes, you might also raise a property change event for full name change. And oftentimes developers have to do that manually, and there have been I've seen different things, especially in different clients I've worked with before, where we've made maybe added an attribute like maybe you might have a property attribute like this, something like that, or maybe nowadays you'd have like name of. But the basic idea is that this is an explicit dependency if you were to be tracking things that way. And the calculated properties do all that for you. So, and they only, especially with these fixes, they only advertise that they've changed when they've actually changed. So for developing complex view models that have dependencies on other view models and things of that nature, it basically handles all that for you. So the reactive view model, for anybody doing MVVM, is a pretty nice advance on kind of the state of the art. Technically, anybody who needs like blistering speed performance will still do better to hand code a view model, because there is some performance overhead for that state tracking. It's not free, but view models, the idea is that the properties really aren't changing all that often. So when you do have a change, it's a more significant event. You've got some user input, something of that nature. So those really only need to operate at kind of user speed, which is like timing on the order of like milliseconds and sub-milliseconds is going to be fine. When you're doing like system programming, you need things to run at like microsecond or below speed. You probably aren't using view models anyway. But if somebody had a really complex UI with thousands of view models in it, the reactive view model may not be a good choice for that, just because of the extra memory overhead or the performance overhead. If it was having to evaluate conditions thousands of times, maybe in like a grid scenario or something like that, that may be an issue where somebody wouldn't use it. But for simpler UI, the reactive view model is a really, really fast way to get things set up. And one of the nice things is if you're developing a UI, if it turned out to be a case where you needed to optimize a certain point, you might start with everything as reactive view models, and then on a case-by-case basis, hand replace some of them. Like if there was grids where you needed 20,000 items in a grid or something like that, you might create a special case view model for that case, where it's hand coded to get a little bit better efficiency. But the rest of your scenarios, you might go ahead and use the reactive view model. I haven't personally tested it in a situation where I've ever needed to refactor it out, but I could imagine a case like that. And I have built some really complex UIs with the reactive view model where I do have thousands of view models and my performance was still really good. I just mentioned that as a hypothetical. But in my cameraman here, I mean, he's got a bunch of properties that are being raised very frequently as he's monitoring these different real-time conditions, like where my mouse is, the audio input levels, and things like that. And even though those are changing constantly based on my actions, the overall cameraman app is still running near zero CPU. So the performance on the reactive view model is actually really nice. There's very few cases where I think somebody would need to resort to hand coding. But the win behavior, getting back to that, I want to implement more robust state management. So that's what I'm going to be doing in this video. I'm going to record, I'm going to implement a case using the state pattern, state machine pattern, where I'm going to have a base class for states and implement still getting over my pneumonia. I'm going to implement all the cases as derived classes for the various states that I can end up in. And for me, that's going to be no camera, small camera, and big camera. Those are my main states. The lighting conditions as well are going to be aspects of those state transitions. And my lighting right now where I've got that implemented is fairly simple. I may end up leaving that in my XAML because it's basically like if I need the light on, turn them on. If I don't need them on, turn them off. The logic there is not too bad. Same thing with my monitor switching code. The logic there is really simple. I'll probably end up putting that all into my state classes though. And I'll get rid of the XAML-based approach, but the priority is going to be for the camera states. So the very first thing I'm going to do is spin up a new class. I'll probably, let's call it a camera state because the camera state will be none, will be one of the options. And I don't know yet what my object model is going to look like, but I do know my resultant states. And I'm going to have go ahead and move that into a new class, new file. Come on, ReSharper. And I know I'm going to have a grab that from my constructor. And then I'll have on here so I'm going to have a track where the lighting is required based on any state other than none. Cameras on, lighting's required. And I'm also let's see, I think I will I'll have a method. Make that abstract. So the basic idea is I'm going to have my desired state view model here have an instance of what state he's currently in. Yeah, I'll put that in the... So I've got these nice little macros. That I've set up with a ReSharper that allow me to quickly insert view model properties. So what I want to do is have it on my timer. I basically want to I want to be sending in, like every time there's a timer event, I want to be calling the what did I just call that property? I didn't give it a proper name. State. Now, really, this thing isn't a camera state. It's going to be a scene state. So let's call it that. I'm really tracking tracking which scene I'm going to end up in. Monitor state. Is this going to be a view model? I'm not going to put this here yet because I don't know where I'm going to want this. Yeah, it's fine. I don't need to have those implemented yet. No. I'm probably going to have the ability to switch the monitor for the lighting state and keep it on the no camera, small camera, and big camera. Those are going to be my main flavors. So those have different logic, whereas the lighting and the monitor are going to just be aspects. The logic on those is really simple. So it's not going to cause it to have a different set of logic. The only logic that's going to be different is going to be based on the camera. So if I were going to have a situation where I've got more complex state, I'd end up having the state controller as implementation of the state pattern for each of those aspects. You might have a single state class that's your resultant state. You might have different aspects of that that are pluggable. So in this I'm not gonna need something that robust because my state is a little bit simpler. though I might want to have a state that could be represented as a transition. I'll figure that out as I go. So in my on timer ticked, so base scene state. The basic idea is after I evaluate some of these conditions, I'm going to say I want to evaluate it. I may actually just want to pass it an instance of each of those: lighting, OBS, audio, and input. OBS last. Alrighty. Now, essentially, what I'm going to be doing is transposing logic that I've currently got implemented in these conditions here into my evaluate method. So the first one I will need is for what to do when I'm in no camera. And this condition is going to only apply when there's currently no camera being shown. And I'm going to want to look at my conditions here. Yeah, I think I also need the desired state model. So let's see. Come on, IntelliSense, don't fight me. Let's see if the audio controller. I'm gonna grab this down because that's a I'll be looking at more closely. Let's see, that is redundant. Let me look at places where I use that. All right, so now I'm going to look to see if I think first I'll have the rule for the big camera. I don't even remember what I have on how that works. How do I set that? Okay, so I do need to check that. The big camera is allowed, and start state. Allow straight to big cam. Okay, so if he's allowed to go straight to big camera, this is based on timing, and I don't have recent input. See, I'll probably have a class. The basic idea here is I'm going to have a state that is going to be responsible for executing my transitions. I know that's not going to be the final logic. I'm going to worry about that in a minute. Something like that. And if we have to go into small camera, I can't have the mouse in the bottom right. I check my input controller. All right. Oh, I think that is more or less all the logic I had. If I'm in the small camera, I can show the big camera, or I can hide the small camera. And hide the small camera is really a specialization of the small camera scene state. Okay, so if the input is mouse in the hot zone, I'm going to do a new transition. And otherwise, if he doesn't have recent input and big camera is allowed, and audio controller suggested camera state big. So again, I'm going to have a little bit of needed use of this. If the suggested camera state is none, not null. My transition state, I think he's going to need to be a little bit more robust than this. Let me think. The suggested camera is none. Oh, hello, dog. Are you coming back? I'm gonna need to take a break and go get him some food. I'll be right back.